All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I'm really excited about this one. We got a demo, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use the question and answer tab on your interface and submit your questions, and we'll try to get to as many as we can near the end of the webinar today. We also have a very active public chat section on the interface, so we'll be chatting out and hopefully you'll be chatting back to us. Please feel free to give us your comments, suggestions, questions, anything you want to share with us. We'll be more than happy to take it. We also have a number of handouts in the handouts section that are free for you to take a look at and download and take with you. So feel free to check that out at your leisure during the webinar. Also, the slides are as part of those handouts. So anybody who's looking for the slides, there they are. What else? We have 3 polls during today's webinar. So pretty much we got everything you need for a complete webinar to keep you happy and engaged. So please stick around because at the end we've got 4 Amazon gift cards that we're going to be giving away, $25 Amazon gift cards, but you got to be here to win them. So there we have it. All right, so let's kick off today's webinar because I think I've run out of things to say, which is Secure by Design with Snyk and Docker. Our speakers today are Peter McKee, who is the Developer Relations Manager at Docker. Hi, Peter. How you doing?
Good. How are you? Thanks for having me.
Good. And Clinton, is it Herget?
Herget,
right? All right, great. Principal Solutions Engineer at Snyk. Gentlemen, thank you both for being here. And Peter, I know you are going to be kicking us off, so I'm going to take myself off camera, put myself on mute. I'll be in the background. If you guys need me, just holler.
All right. Thank you so much for that introduction. Yeah, like Charlene said, my name is Peter McKee. I'm the head of developer relations at Docker. Super excited to be here. And I'm joined by Clinton, who is my new best friend on all things security scanning related from Snyk. How are you doing, Clinton?
I'm doing great today, Peter. Thank you for having me. And thank you, Charlene, for getting us kicked off. Really excited to talk about how to secure container build processes today.
Yeah. And so I think we got, like Charlene mentioned, we have some demos, some really cool stuff. We were just fixing things right before. So you're getting things live, unedited, raw, real world stuff. So super excited about it. Why don't we just jump right into it?
Yeah, absolutely.
Okay, awesome. So what did Docker and Snyk do? So if you don't know what Docker is, shame on you. No, I'm just kidding. But we have the world's #1 containerization platform tool set. If you haven't downloaded Docker Desktop yet and you run on a Mac or Windows, please go to docker.com, download our desktop. We're going to talk a little bit more about that later. But yeah, Docker is really focused on the developer, the containerization tool set, how you can build, share, and run your applications. And then we partnered up with Snyk, who is a world leader in vulnerability scanning and fixing vulnerabilities through open source libraries, containers, infrastructure as code, and many other things. Again, we're going to be going through a lot of that stuff today. Maybe next slide, Clinton. Yeah, and so why the partnership? Why do we integrate with Snyk? So on our roadmap, we have a public roadmap that's on github.com/docker/roadmap. And I'll put this link in the chat. But that is our public roadmap. We do spend a lot of time in there, all the way from our CEO down to our engineers. So if you have a feature request, please go check out the roadmap and add it in there. But we had the #1 feature request was around security. And so we took a look at Snyk, and they also have a developer first, a developer obsession. And so it made a great sense to partner up with them, bring in Snyk's security and vulnerability fixing, finding and fixing vulnerabilities. And we made it as easy as running Docker run. So running Docker scan, and you're going to see that a lot today. But yeah, so excited to be partnering up with Snyk. And yeah, so let's jump right into it. I think we have a polling question kick things off, love to get to know you guys a little bit better. So on a scale of 1 to 5, how familiar are you with container vulnerability scanning technology? 1, never heard of it. 2, somewhat familiar. 3, familiar with it. 4, familiar with it and currently use it or plan to use it. And 5, highly knowledgeable. So if you would take a minute and answer, I'm going to say 5, highly knowledgeable, because what the heck. But yeah, please take a little bit, answer that poll, but we're going to move on, and we'll come back to those answers in a little bit, give you guys some time to answer. Over to you, Clinton, all the exciting stuff.
Awesome. Thanks, Peter. You're a bold man choosing 5. I went with 4. I think I'm familiar with it, currently use it, highly knowledgeable, hope to get there one day. But definitely am excited to be talking today about all the great things we're doing here with Snyk in combination with Docker. So we would love to get back to the poll results in just a minute here. But to take a second, I think probably most folks in the DevOps community familiar with Docker may not have as much familiarity with Snyk and what we're doing. To kind of put it, succinctly, Snyk is a developer-first cloud-native application security company, and we're looking to help developers secure all the aspects of a modern cloud-native application. And what does that mean? I'm an old guy. I don't know if you're an old guy, Peter, but I kind of came up in the day where this diagram would have looked quite a bit different. Maybe 10 years ago, even 5 years ago, where applications were much more based on custom code, right? Everything was built in-house with invented here proprietary code. And then to deliver that, to deploy that into production, what would you do? You maybe make a tarball out of that, throw that over to an ops team who would then try and run it on a VM or even a bare metal server. And what would they say? We've all been there, right? They'd say it's not working, right? There's some dependency that's not met. There's something in the operating system that's not being able to run your application. Throw it back to the developer who would say, hey, it works on my machine, right? So part of what the cloud native software supply chain tries to correct is making that a lot easier and easing those tensions between development and operations. So that's where things like containers come into play. Also, open source is a big aspect of all software development today. It's much less about building things and construction and crafting one line at a time, and much more about assembly, right? It's the sort of IKEA model of software development. Pull something off the shelf, assemble it, combine it with other pieces to really create your application. And then more and more, we're seeing infrastructure as code as well, being a part of modern cloud applications, living in the repository alongside things like the Docker file, things like your open source package manifest and your custom code. And it's developers who are writing those files. So think of things like Kubernetes manifests maybe, or CloudFormation or Terraform, the code that actually configures how this application is going to run out on some cloud resources. So the Snyk platform is designed around these 4 aspects. How can we provide security for open source code, containers, infrastructure, and custom code that's targeted at the developer, right? Because that's when fixing vulnerabilities is going to be cheapest, is actually inside that development process. And not a lot of security tools are really designed to enable developers both to detect issues early in their workflow, to integrate with the other tools and processes they're already using, and most importantly, to be able to remediate. Like, once I've identified an issue, how can I fix it? What can I do about it? So that's what we're going to talk about today, is kind of through our partnership with Docker, how Snyk is able to provide a lot of these tools right within the developer experience. And we're going to focus mostly on the container security issue, but I'll also touch on why it's important to be scanning your open source code, your custom code, and your infrastructure as code as well. With me so far, Peter? Not saying anything too far
Yes,
off
sir.
the beaten path here? Awesome.
You're right on target, sir.
Excellent. But why is container security in particular more important? As you pointed out, Peter, it's kind of the number one item on Docker's roadmap, and it's definitely something that Snyk has invested heavily in. And it's precisely because containers solve that problem that I mentioned, where no longer do we have to worry about something that works on my machine but not in production, right? I take that application, I put it in a container, I build it, I ship the container image as my deliverable, and I know it's going to work the same way once it's on some kind of cluster or some kind of cloud resource up in production. And that's great because it's a really rapid development process. I don't have to worry about configuring my database instance or installing Linux packages or figuring out what version of a library that I need under the hood. I can actually just say from, as the top line in my Docker file, and then the ecosystem that I need, whether that's a OpenJDK or a Node.js or a Python. And I know all those supporting packages are going to be there with the exact same versions that are going to run later on. So it's this really rapid development that's you're able to embrace with containers. The problem with that is you bring a lot of vulnerabilities along for the ride, right? So if I go out and say, pick a base image for the ecosystem that I need to support my application, the developer who built that base image was also pulling from something, right? Maybe from a Linux distribution under the hood, or some other kind of middleware container image. And all of the vulnerabilities in the parent image end up in the image I just built, and so on and so on and so on. So at every layer of the container build process, you're getting more and more potentially vulnerable packages. And so we went out and did some research in conjunction with Gartner, a couple years ago. So this is in 2019. The problem's really only gotten worse since then, showing 75+% of global organizations are going to be running containerized applications in production by next year, right? And that number might have already been eclipsed. So the ease of use of containers really can't be argued at this point. But if you look at, for example, public images on Docker Hub, the top 10 most popular images, so you were talking public container images that any developer can pull down and use in their applications, all have at least 30 vulnerabilities associated with them. And 76% of the top 1,000 containers of public images in Docker Hub have high severity known vulnerabilities. So it's the very thing that makes containers sort of so easy to use and lends themselves to such rapid development that actually makes them insecure at the same time. What's needed, though, is a security solution that developers can actually use in the process of building those containerized applications, so they can both identify and remediate those issues where it makes sense, which is in that developer workflow. Do we want to check in maybe on the results of our poll question that we asked a couple minutes ago?
I will be more than happy to let you guys know the poll results. We had almost 100% participation, which is awesome. On a scale of 1 to 5, how familiar are you with container vulnerability scanning technology? The largest percentage, 39%, said they are somewhat familiar. And the next largest number, 20%, said they are familiar with it. 18% said they are familiar with it and currently use it or plan to use it. And 16% said they've never heard of it. So then we have 7% who said they're highly knowledgeable. That's including Peter, of course. So take that one as you go. So,
Peter's always representing that.
That's right.
Doing the numbers already.
There you go.
Well, at the very least, I hope that of the 16% that said, not familiar, that we're able to move the needle at least a little bit here in maybe the next 40 minutes or so. Great. So I think we've kind of talked about the problem, right? Like why does container security pose such a big issue in this cloud native application sort of supply chain? So I think maybe let's step through what can a developer actually do about that, right? And so what we've done in combination with Docker is come up with this model for DevSecOps, or if you think of it as maybe a secure SDLC pipeline. And what you see throughout is that there are opportunities to embrace security kind of across this entire pipeline or process, all the way from the coding phase, where developers are actually in the application, picking out base container images, writing their Docker file, building the app, picking their open source libraries, all the way through out into production. And along the way, Snyk and Docker can help both inform by identifying vulnerabilities and then also pointing to the fix. So what we're going to show in just a second here is utilizing Docker Desktop, or the Docker CLI, to actually identify vulnerabilities in container images as I'm building them, right? And alongside that, actually say, here's the fix. Here's where this package is coming in. Here's what you can do about it as a developer. So before I've even committed, that Docker file, pushed it into my GitHub repo, for example, I can already have, completed the loop all the way through from identification, prioritization, into remediation. So really powerful stuff that can happen as part of the developer workflow, where those loops can kind of be fastest. Beyond that, though, it would be great to say we want to rely on developers to do self-assessment, right, for all vulnerabilities, and that's going to be 100% effective. And it's, maybe not always, right? So it's also important to have security gates across that SDLC, but they need to be lightweight. They need to be useful for developers, which means they need to include not just, again, identifying the vulnerability, but the fix at the same time. So one of the ways we can do that at Snyk is inside the Git repository, for example, inside GitHub, be checking pull requests as they come in, looking at vulnerabilities in the Docker file, certainly, but also in things like your open source dependency tree, in your infrastructure as code files. Use that as a way to, once that code is checked in, when the pull request is created, be able to apply a security policy right out of the gate, sort of as far left, if you want to use that terminology, as possible. That then typically triggers a build, right? You make a commit, push that up to the mainline branch, CI/CD pipeline takes over. Maybe that's a GitHub Actions or a Jenkins, something like that. Then builds the application and ultimately makes the decision about whether to deploy that out. That's another great place to, again, add some kind of security gating functionality to determine whether that build should succeed or not. We can talk through how to do that with Snyk and with the Docker CLI. Then that application's built, kind of put into the container image, and then typically pushed into a registry, right? And this is where sort of the trust boundary comes into effect. So I've created my image, and then I'm sticking it into my registry as sort of the source of truth, right? This is the runnable state of the application. And here's another place where, Docker Hub, obviously, as a very fully functional container registry, we can also integrate security. So we can scan container images sitting in the registry in Docker Hub for vulnerabilities. And more importantly, we can monitor them, right? So I could have an image that maybe it doesn't have vulnerabilities today, or maybe I accept the risk as they're moving through that CI/CD build process. But then once they end up in the registry, they could be there for quite some time, right? Kubernetes clusters and things are pulling them to be able to deploy new pods and so forth. How do we know that new vulnerabilities aren't being found? That's why that proactive monitoring is important. So we'll talk through what that looks like and really see the power combining Snyk's vulnerability intelligence with the functionality that you're getting from using Docker Hub as a container registry to really establish this is a trusted repository of containers. And if you excuse me, because I talked too long there, here we go, we're back. So that's kind of the general story of how Snyk in combination with Docker can protect across that SDLC. Everything I'm saying makes sense so far from your perspective, Peter?
Yeah, absolutely. Absolutely. Awesome.
So I think, do we want to take a quick pause, maybe talk about question number 2, and then we can dive in and start having some fun with the demo here?
Yeah, that sounds great.
Great. Right, so this is,
sorry.
Yep, go ahead.
Sorry, I was going to push out the poll to everybody and let them know the question should be out to you now, so you can go ahead and make your choice, and you guys can continue on with your presentation.
Awesome. Yes, the question here is, what would be most useful to help you start or improve your container vulnerability scanning experience? So with this basically like a short guide on how to get started, more easy to understand documentation, more information on quick ways to fix vulnerabilities, video tutorials with use case examples, guided in-person lab workshop, or user testimonials. So I guess what kind of content do you want to consume when it comes to this type of security enablement? I think I'm gonna pick, since we're doing a demo today, I'm gonna pick a guided in-person lab workshop, just to assume that I'm delivering the kind of content that people want to hear.
Awesome.
All right. So definitely take a look at that poll question. But in the meantime, I want to get to let the rubber meet the road here, show what this looks like as part of a real application. So if I just pop out of my slides, I'm going to be using an application that we use a lot here at Snyk. It's called Goof. It's an intentionally vulnerable Node.js application. So if you want to play along, you're more than welcome to go here to GitHub/Snyk/Goof, and it's a public repo. You can clone this and play along with what we're going to be doing today. It's got the Docker file in here to build the application, which I'll show in a second, along with kind of everything you need to bring it up and running. This already exists, right? We've already chosen a base image for this application, but kind of backing up, if I'm a developer who's just starting out and I say, all right, I want to build a containerized app, well, maybe I want to start with Node.js as my ecosystem. what should I be looking at in terms of choosing a base image, right? Because as we talked about, the speed and the ease of use of containers comes from the fact that I can pull a base image that already has the entire kind of platform or ecosystem baked in under the hood. And until now, developers haven't had a great way to determine, well, of all those base images that are available, what's going to be the most secure, or at least what's that going to do to my vulnerability footprint? So one thing we did at Snyk was introduce something called Snyk Advisor, and that is now up and running for Docker images as well through our partnership. So I can actually go here to snyk.io/advisor, pull this down to Docker, and search for images that are in the public Docker Hub repository. So here I've got Node, right, which is going to be my the namespace I want to use. We can give you at the outset, so this is sort of allowing you to make better design decisions about what goes in to your container images based on the number of vulnerabilities. So we can say, you know, the node 15.14 Debian Buster image has 25 high severity issues, which is actually a little bit better than the latest tag, which has 55 high severity issues, right? So as you're making these decisions, Snyk can help from the design phase out just by, you know, constantly giving these scan results around vulnerabilities in public Docker images. So just wanted to point that out. If you're kind of just getting started on that container journey, Snyk Advisor is a great place to sort of all together, you know, in under one pane of glass, get information on what image should I be using sort of right out of the gate. So if you're playing along, hopefully you've got this repo cloned. I want to go ahead and jump into the command line and start having some real fun here. So this is where I've got my my repository checked out, and I've got this this Docker file in place here. So if I'll cat that, we're doing some pretty standard things, right? We're declaring our base image, we're installing some packages, we're exposing ports, we're running, in this case, npm update to install my dependencies, and then we're saying this is an npm app. So my entry point is npm start. I'll actually show this in my editor here, make it a little bit easier to see. I have changed this a couple of different ways from the version in the Git repo. First of all, I actually used a slightly older Node.js image. I picked Node 10.4. We'll see why in just a second here. I also added this line to install another package. So maybe I want to improve this app by adding some image-based functionality, right? So I'm going to install this library, ImageMagick, onto the container, which doesn't exist on the Node 10 base image, right? So what we're doing here is adding a user layer or user instruction, which says on top of this Node 10.4, run this apt-get install ImageMagick command, right? This is a Debian-based image, so apt is the package manager. ImageMagick is the package I want to install, which is then going to install a bunch of other transitive dependencies and things like that under the hood, and then continue with the rest of these build steps here. So I'm here on my command line, and I think I can go ahead and say Docker build, right? Because we want to turn this Docker file into an image. I'm going to give it a tag. I'm going to call it goof because that's the name of my application. And then I'm going to say in the current directory is where you're going to find the Docker file. That's going to do a bunch of churning and send that off to the build context, and then it's going to step through each of these build instructions, right? Anybody who's kind of built a container pretty familiar with this part. We're going to pull the base image. We're going to install that package, set the ports and everything. So now I've got my image built. Everything's great. This application, right, I mentioned it's Node.js. It does have a dependency. It uses MongoDB as its backend. Fortunately, because I'm using Docker, I don't have to worry about building a whole separate Mongo container, right? I can actually just pull that from, again, Docker Hub and run it, you know, just run the image kind of as is. So I'm actually going to find a command here where I've got Docker run, and I'm going to call this container goof Mongo. I'm going to give it a network, and I'm going to specify that I want to run the Mongo image, right? So now we've got that up and running. And so now finally, I can actually run my, my goof image itself. So I'm going to map a port, right, from my localhost 8080 to the Node.js port, which is 3001. I'm going to give it this environment variable, which basically just tells the image to use the goof Mongo connection. I'm going to make sure these are both on the same network so that they're connected together. And then finally, give it the container we just built, which is called goof. So that's going to get up and running. Now, if I did everything correctly, here's the big moment of truth. I should have my app here, right? So goof to do. So this is the app up and running in a container environment. I'm going to give myself a little to-do list item here, which is the devops.com Docker webinar with Peter. and that's going to be added to my to-do list, right? So my app's up and running. So are we done, Peter? Is this the end of the demo?
Sure.
I'm gonna do just one more thing, right? Because one thing we haven't talked about at all is security, right? So what actually has happened here is I've pulled an image, right, from actually from a public Docker Hub repo, packaged it in an app. I could just take this and push it off, right, into a container registry, wipe my hands, and say my job is done as a developer. I'm not going to do that though, because I have a nagging concern that there might be, some vulnerability associated with this image. So what I'm actually going to do is use, as you mentioned, and I'll clear this out to make this a little easier to see. I'm going to run the Docker scan command here. And what this is going to do is look at the container image I've built and find any vulnerabilities, which are known CVEs associated with the underlying Linux packages on this container image. So I'm going to actually give this the name of the image that we built, which is goof, and then I'm going to give it the Docker file that we used to build it. And I'm going to tell you why in just a second. So we're going to set this off. Docker scan actually utilizes Snyk on the back end. So we'll talk in a minute about how there's also a Snyk CLI where you can run Snyk container test, which is going to give you the same results, right? So Docker is actually taking this, passing it off to Snyk. I should mention that this is in, I believe, the latest stable versions of Docker Desktop, if I have that right. And I was excited to find out this is available on the Linux version as well, which is actually what I'm using here.
Yeah, and that's just brand new. Hey, Clinton, while that's scanning, got a couple questions.
Sure.
A couple questions here. So James asked, and I think I could do publish. Uh-oh, maybe I did that. Okay, there we are. How prevalent are vulnerabilities of images from cloud providers? Hyperscale like Azure, AWS, second tier like Linode and DigitalOcean. I'll take a quick stab at that at a very high level. You're going to have vulnerabilities everywhere, right? And I think Clinton can better talk about this and I think you kind of hinted at it earlier, right? What's your risk factor, right? What vulnerabilities are you willing to accept because of attack surfaces and those type of things? But that would be my general answer, that you have vulnerabilities everywhere. I don't know, Clinton, what's your thoughts?
Yeah, I think a lot of people are surprised to find out actually how many vulnerabilities you'll find in a lot of these container images. And part of that is because a lot of them are based on sort of fully fledged Linux distributions under the hood, right? So I might have a microservice, in this case, a Node.js app. But in this case, this is actually built, you can see it here because of this little deprecation warning. This is built on a full Debian 8 install, right? And if I were to look at, we can actually show later in the Snyk interface, all of the packages that end up on this container. And that's why some of these images, first of all, end up being so big, but second of all, have so many vulnerabilities. Does the node runtime need all those dependencies under the hood? Probably not. And that's why you end up with things like -slim containers, for example, where it's really only using a subset of those packages. So I would say it has less to do with specific cloud providers, right? Specific maintainers of images, and more to do with ultimately what is the underlying, Linux file system that image is based on, and how many packages really need to be there. And there's lots of solutions to this problem in particular, things like distroless images that Google has published some things around. You can build scratch images, which is start with an empty container and kind of add packages to it, or copy binaries in or something like that. So lots of ways to handle that. But I think the big takeaway here is, you can kind of be shocked at the number of vulnerabilities that end up. I just ran this scan, as you can see, and I've got this big giant list of flashing red of issues in my container here. I've got 958 total vulnerabilities in the image I just scanned, right? Of those, 454 are high severity issues. So just a huge amount of vulnerabilities. And if I look a little bit deeper, I can actually see that the majority of those are coming from this base image from Node 10.4. So it's not that I've done anything in my Docker file to introduce all of the vulnerabilities, so much as they already existed in the parent image, right? And so now I'm dealing with everything that I imported, and it's up to me as the developer to make some better decisions here about how I want to proceed with building this container.
Yeah. And what's really interesting is that's a shift probably within your organizations, right? I've been around long enough, Clinton and I have been around long enough where we didn't worry about the OS, right? And when you're building your container and you're building a base image that, like Clinton was saying, that has your OS in it, developers need to be more aware what is in your image, right? And there's different ways to approach that within your org and the different boundaries, right, of base images and those type of things. Not sure we want to dive too deep into that, but Clinton, real quick, because I think this is a fast one. How do I access the Snyk Advisor?
Oh, yeah, absolutely. I think we had flashed that up for just a second here, but to reiterate, it's snyk.io, which is our website, /advisor, ADVISOR. So we can stick this link in the chat as well, so you can have access to it. And I should mention that while it does work for Docker images, we do have NPM and Python packages available as well. So if you're just a developer in one of those ecosystems, you want to find out what are the vulnerabilities associated with this package versus maybe some others. What are the transitive dependencies? Advisor is a great way to do that, really before you've even started building out the application.
Yeah, I think that's awesome. I think there's a lot of developers go, oh, well, just grab a package off of NPM, right? Well, who wrote that? What's in it? Is it, and these are real things, right? Is it mining Bitcoin, right?
Yeah.
Underneath the covers, right?
Well, and yeah, remember, and this is true of the container problem as well. It's not just the dependencies you know about, right? It's all of their dependencies and the kind of term of art is transitive dependencies. I might have 7 packages my application relies on, but each of those could have 25 other dependencies and so on. So you end up with these massive dependency trees, and there's a big visibility problem for the developer. Containers often really just kind of make that worse, right? Because a container really is just another collection of open source dependencies. They happen to be Linux packages, but from the developer perspective, like this is just more open source code that I need to support my application. I'm not seeing the full extent of that. I'm really just seeing, I use Node 10.4. Now I've got 900 and 58 vulnerabilities. What can I really do about that? So to take a stab at answering that question, when you're coming at it from the container perspective, really it's the two things, or the first decision you want to make is really between two things. There's 2 ways a vulnerability can get into a container image that I've built, and functionally that means either it already existed in the base image or in the parent that I declared at the top of that Docker file, or it's something that I added as a result of those user layers, right? The instructions that I'm writing to build my container image. So what Snyk does, and again, this is powering the Docker scan functionality, is we'll actually indicate which image layer it came from. My highlighting is not super great here, but hopefully you can see the line I'm pointing to. If this vulnerability was introduced because of a command that I am running, so it's in my user layer in my Docker file, we'll actually identify the line that came from. So this vulnerability, this is a critical severity issue, an out of bounds read in lib freetype6-dev. So this is the Linux package that it's affecting. This package is on the container because I ran that apt install ImageMagick package in my Docker file, right? So the remediation then is I actually have to make a change to either, I could remove this, but I could also upgrade the package, and we'll give you the remediation advice here. We'll tell you the fixed version of the package that contains the vulnerability, so I can very easily take action on this as a developer. The second way, though, a vulnerability gets introduced, and probably the more common one, is it already existed in my base image, right? I'm not going to go and install hundreds of packages by myself. I'm going to rely on what's in Node 10.4. And so here, if to use the second one, this is a critical, again, issue found in the file package, again, on Debian 8. That already existed in Node 10.4. Right? So there was really nothing I could have done about that to use this base image. We will indicate the fixed version. So I could, if I wanted to, go into my Docker file and say install file 1.5.22-15 to remediate this issue. The problem is that's not really a best practice for container image management, right? Like I lose all of the economies of scale I get from using base images and from layering things on top of them if I'm essentially maintaining my own Linux distribution under the hood, right? So of these 958 issues we're dealing with here, I probably don't want to go in 900 times and be upgrading individual packages, right? Because that's what I'd spend all my time doing. Then I'm not a developer anymore. I'm a base image maintainer. what I can do is I can pick a more secure base image to start with, right? And we saw this when we were looking at Snyk Advisor. We actually will give the same information in conjunction with this container scan on the command line, where we'll say, okay, you're using node 10.4 currently, 958 issues, 454 are high severity or critical. Here are some other options. So here are other tags in that namespace, and in this case, I pulled this from Docker Hub. So we're looking at other node images in Docker Hub. And here are some alternative base images you might want to consider using. So for example, we'll look at a minor upgrade here. If I were to upgrade from 10.4 to 10.24, for example, I can actually cut my total vuln count almost in half, right? 958 to 530. My high severity count goes down from 454 to 57, right? Just by making the most minor upgrade available to that image. So I'm getting massive improvement here just by changing my base image to one that's like a little bit further along, 10.4 to 10.24 here. But what we can also do is give some other suggestions that might have even better vulnerability coverage. So what we've seen is that if I go to, say, the node 10.24-slim, right? Again, it's these 5 characters that make all the difference. I'm then going to be using a different underlying, in this case, Debian distribution with far fewer packages. I'll still be able to support everything I need from the node ecosystem, but it really limits my vulnerability footprint. So I can go from this 454 down to just 16 high severity issues by adding these 5 characters, right? By going to the -slim. So there's kind of major improvements to be made just by looking at a more secure base image with fewer vulnerabilities to begin with.
Yeah. Clinton, great question here. So James asks, is 57 high severity vulnerabilities okay? Question mark it. It's a massive improvement from 100, but is it good enough? Great question. Yeah.
It is a great question, and I think that's what a lot of container security folks and developers are struggling with, right? Like, what is good enough, right? So first of all, I would say yes, like make the improvements that you need. Once I go down from the 450 down to the 16, I can then start to get a sense of, well, what's remaining here, right? What kinds of vulnerabilities are these? Are there other ways to mitigate? Can I install updated versions of some of those packages manually, or might I be able to integrate remediate in other ways, right? By firewall rules, by changing things in the application, by doing different things under the hood in the Linux architecture. So yeah, like the first step really needs to be, let's get down to the bare minimum of vulnerabilities, and that's when a security team can really come in and help, and risk analysis really starts to apply, right? That's a lot more difficult to do when you're dealing with 450 issues than you are with 16, right? So let's get the low-hanging fruit taken care of first, and then we can start iterating over, well, what vulnerabilities are remaining? Do these packages need to be there? Are there other ways we can mitigate and sort of move forward from there?
Yeah, great.
Any other questions? I'm just kind of scanning through for what else might have come up here in the last few minutes.
Yeah, there's a question about false positives. That if you want to attack, and then there in the demo, I can't remember if we get all the way through a CI/CD pipeline, but we definitely have more resources for that for sure that we can share out.
Yeah, for sure. So it definitely can link to some issues there. I think what I'll do from here is kind of show the steps that would be involved in a CI/CD pipeline, and then those can easily be kind of scripted together. On the Snyk side, we've definitely got a lot of plugins for things like Jenkins and Circle CI and TeamCity, all the kind of big CI providers. But at the core of that is really what you're seeing here. It's this combination of the Snyk CLI along with the Docker scan functionality that gets at a lot of these issues. So you can do things like set a severity threshold, for example. So if I wanted to run something like Snyk, if I get back into my window here, Snyk container test, and goof, what gives the name of my image, I can say something like severity threshold equals high. What that's going to do is run the same test, but then if I've got any high severity issues here, it will actually fail to build. So it'll pass an exit code that can then be interpreted by my pipeline to say, wait a minute, this exceeds the threshold that you've set as part of this command line. I can do other things as well, like I can say exclude base image vulns. This is another really popular one. I think I've got this right. But what this will do is basically say only test those issues that I'm responsible for in my Docker file, right? So maybe I've got another team that's actually maintaining the the middleware image or the base images, and I'm only responsible for the vulns that are in the layers that I'm producing, right? So that's another way to do that. There is an ultimate kind of expert mode, which I love to show. I'll actually put this Docker file line back in here, which is --JSON. And this is taking all of that data from the test and actually giving you the full JSON data set. So then I can write scripting around this to basically say, look for specific CVSS scores, look for specific CWEs, right? To get back to the question about, is 57 high or not? Well, it might depend on how those are exploited, right? Are we talking about SQL injections or cross-site scripting issues, or there's going to be different kinds of weaknesses designated by the CWE under the hood. I might want to do some analysis on that. So the kind of expert mode here is to take this data set in JSON and then figure out. So now I've got all my vulnerabilities, and I can really parse through that to determine. I've got my my 958, all my vulnerable paths. I have all the info in terms of the fixed version here, the whether it's patchable, whether it's fixable, etc. So lots of other kind of goodness I can have access to there.
Yeah, awesome. And those flags are available in the Docker scan command also.
Awesome.
Which is awesome. They weren't originally, but they're there. I was super excited about the severity for sure.
Perfect. Yeah, I wasn't totally sure about that, but I figured you'd correct me. So great.
No, and to be honest, I had to go, are we live with that yet? And I went and checked it real quick. So
fantastic.
Yep.
Cool. So let's continue here. I know we've been taking up a lot of time, but let me go ahead and do the next kind of phase of this in CI/CD, which would be a push, right? And I'm actually going to tag this image that we just built here with a tag from my repo in Docker Hub. And if I find that, what we'll do is actually push this into the repository and then show how we're able to scan at that point. So, all right, maybe I've made all my decisions about remediation. I've rebuilt the image, and then I want to say Docker. First of all, tag it. Whoops, food. Boy, what do I have on mine today? Goof. And I believe this is, give me just a second here. Have to find the right namespace to stick this in. Organizations,
well,
labs, there it is.
Oh, I was going to say, Clint, while you're doing that, you want to take a look at the results of the second poll?
Oh, yeah, let's do that.
I was hoping you guys hadn't forgotten about me here. So, all right. So the second poll was, please tell us what would be most useful to help you start or improve your container scanning experience. The largest percentage, 41%, said video tutorials on how to get started with extensive use case examples. That's a great way. And I know a lot of organizations are doing that. Excuse me. The second largest percentage, 21%, said guided in-person lab workshops. So, hey, these webinars fit right into that, right? 18% actually said a short guide on how to get started. And 13% said more information on quick ways to fix vulnerabilities. 8% said more easy to understand documentation. That's it. Nobody said user testimonials. So,
no, I don't know that I'm that surprised there. Yeah, that sounds like a highly technical crowd on the line, which is always a good sign. So, Peter, I don't know if you saw, I went ahead and tagged this image once I figured out the org it needed to go into here, pushed it up into Docker Hub. And this is really where kind of the power of the combined solution, I think, becomes clear, because now the vulnerability data around this image is actually going to be in the Docker Hub interface. So if I go into my Snyk Labs goof image, we've got vulnerability scanning by Snyk enabled on the image. So if I just jump into here, I now have access to essentially everything we were seeing out on the command line, but it's in Docker Hub. So this is a great way to do continuous monitoring of your images. So I might not have any vulnerabilities, or I might have a number that I accept, push it into the registry. But then tomorrow or in 6 months, there could be another issue discovered somewhere in my dependency tree, right? So this is a way to continuously monitor over time, and Snyk will actually retest these images on a daily basis. You see this one looks like it got scanned earlier the last time I pushed it. We've got those 454 highs because I still haven't remediated. But tomorrow that could be, you know, 455 because a new CVE might be found, even though that dependency tree hasn't changed. So that continuous monitoring is a big part of it as well. After obviously the developer kind of workflow, the CI/CD pushing it into the registry, and then what do you do once your application's kind of already out here in production? That's when you're going to have more stakeholders, right? It's not just the developer, it's the security team, it's, you know, management gets involved. Here's where the risk is really important, and it needs to kind of be continually assessed on an ongoing basis.
Yeah, perfect.
Cool. So I'll kind of jump over as well to show what this looks like from the Snyk side. Great to get this visibility in Docker Hub. You get a lot of eyes on it, certainly, and you get all the other features involved in the container registry here. I can also see this from my Snyk interface. So I can very easily say, I want to add projects, you know, from Docker Hub, and I want to onboard, say the, you know, this image that we just looked at here under Snyk Labs. So I'll just pop in, I'll say I want the latest tag, I want to add. That's how easy it is to say, I want to monitor those images from Docker Hub and Snyk. I can do a lot of interesting things in here as well. Like, for example, I can monitor a GitHub repo. So if I wanted to say, not just test my container, but test things like my open source dependency tree, test my configuration, so my infrastructure as code for potential vulnerabilities. I might have some deployment files or Terraform files in this repo that I want to test, as well as we now do first-party code analysis as well, so static analysis of my actual source code. Again, we're focusing mostly on the container piece today, but these other aspects of application security, all very important. And as you were saying, Peter, I think part of the reason for that drove the partnership between Snyk and Docker is we're both very focused on the developer experience, because it's ultimately the developer that has to fix things, right? You can identify issues all day long, but if they're not prioritized and an engineer looks at them and says, here's how I can remediate, and that process is as painless as possible, then stuff's not getting fixed, right? And at Snyk, we're really not a vulnerability company, we're a fix company, because at the end of the day, what matters is more secure software getting out into production.
Yeah, great point. Great point.
Fantastic. Do we have a third question I think we want to ask?
Yeah, I think there's a great one here. Vladimir. Oh, we're this one. Yes, sorry. I'll be quiet.
No, let's do both. Let's do the poll first, and then we can get back to the Q&A.
Okay. Charlene, I'll kick it off. Are you running container vulnerability scanning on your Docker images today? Yes, no, but plan to in the near future.
I'm interested to see how many people say no, but I don't plan to in the near future. That would be
yeah. I'm going to say yes, because I do for sure.
Yep.
Awesome. Well, do you want to let's grab this question, because I think it's very good. Where do vulnerabilities list come from? Say, who does authorize the vulnerability, right? How often does this list get updated, and in what way? Does it check to exclude code, source code, signature checks, those type of things? So I think generally what he's asking is where do these vulnerabilities come from? How are they updated? Those type of things.
Yeah, absolutely. And love to talk about this because it's obviously incredibly important. You can have all the great flashy tooling in the world, but if you don't have a good source of vulnerability data, you're not going to get more secure. So there are public sources for vulnerabilities. Things like the National Vulnerability Database is one. The problem with using those public sources is they don't give a lot of fidelity, especially not into the things developers care about. So you might get a CVSS score, which is based on something called the vector string. And I can actually show an example here. Let's jump into, this is an NPM scan of my my open source dependencies here. And if I look at, so let's say the zip slip vulnerability, this is in a package called ADM zip in my NPM package tree. So we know it's a critical, right? We know it's a CVSS 9.4. If I then click through to the Snyk Vulnerability Database, I get this information here on the right-hand side is sort of what's coming out of the NVD. And this is sort of what you get, right? It's this really difficult to parse string that ultimately, through some fancy math, ends up as a 9.4 high severity issue. What does that mean to me as a developer? Not much, right? Like that probably means something to a security risk analyst, but that certainly doesn't tell me, how severe is this or what's the priority for me to remediate? And then what can I do about it, right? So what we do at Snyk is we curate all of that public information. So we take the NVD, we take public CVE sources. We first of all verify that's correct because there's a lot of unreliable information in some of those sources. We ensure we're eliminating things like duplicates and false positives and noise that otherwise ends up in a lot of those databases. So when you take that and just kind of script it, which frankly a lot of our other companies are doing, you end up with really unreliable information. There's a question earlier about false positives, right? Typically a big problem with security solutions. What we're doing at Snyk is trying to eliminate or at least minimize that as much as possible by that manual curation process. But then at the same time, we're adding on additional layers of metadata. So all of this here on the left actually explaining to you, what's this ADM zip library even doing, right? What's the vulnerability? How is the exploit potentially crafted? Everything you need to know about remediation. So in this case, I need to upgrade this ADM zip library along with references to the commits that introduced the issue, the ones that remediated it, any kind of information we might have on the exploit itself, right? Advisories, that might be of concern. So this is all created in-house by our R&D team. And frankly, I think that's one of the things Docker noticed when you were sort of working on that roadmap, right? Is that Snyk's got this industry-leading vulnerability database. We have a number of other partners as well that take this data, OEM it into some of their products, right? Because the real hard nut to crack with security is getting a reliable source of this vulnerability data. What Snyk then allows you to do is use that as a way to prioritize remediation, right? So we'll take all of that data, including things like what's the maturity level of the exploit, right? I might have a high severity issue that has no known exploit. There's never been any code detected or any attacks that we can find that have been run against it. But then it might have a medium severity issue that has a mature exploit, meaning we know there are attacks happening against this on a daily basis. I might want to prioritize that one for remediation ahead of the high priority issue or the high severity issue that's never been attacked as far as we can tell. So we take all of that, we roll it into what we call the Snyk priority score, which is helping both the security analysts as well as developers determine what should I fix first, right? Maybe I want to focus on things that have an easy upgrade available, in which case we'll show you what that is. And then we even provide the ability to a one-click fix this vulnerability, make the upgrade in my dependency tree. Now it's remediated. I can kind of move on to the next one on the list.
Yeah. And I just want to emphasize the gravitas of what you just said, right? That's huge. Super, super powerful. Yeah, because I have, prior to Snyk, tried to hunt these things down and figure this out, right? And I'm not a security expert day to day, and it's extremely difficult, right? And Snyk provides all that data in one place and helps give me indicators of when I can fix, when I shouldn't fix, how to think about approaching things, right?
Yep, absolutely. And again, I'll mention one more time that beyond just container issues, which of course are very important as we've seen, there's other sources of vulnerabilities in the application, right? There's what might be happening at the infrastructure layer. This gets really interesting because the blast radius of container issues could potentially be different based on how I'm deploying them, right? So one of the things we're able to do at Snyk is look at, if you've deployed this to a Kubernetes cluster, for example, how is that workload configured and how might that affect that underlying prioritization of the container vulnerabilities? So for example, if I have a container issue that has a specific attack vector, maybe it has a resource exhaustion vector associated with it, which basically means that if this is exploited, it could cause the process the container is running as to fill up its resource quota, essentially. That issue is going to have a much bigger blast radius if the deployment is configured without resource limits, right? Which effectively means that one container could then use up all the resources on the host and effectively shut it down, right? So that's a much bigger problem than just being able to exploit one container. So what our Snyk infrastructure as code solution does is actually allows you to identify a lot of those deployment issues that could exacerbate container vulnerabilities. So we can say, for example, by looking at the YAML file that's deploying this workload into Kubernetes, you don't have your CPU limit defined. here's the impact of this, which is what we just saw. If I have a vulnerability with a resource exhaustion vector, I can then exceed the limits of the actual node. I can crash the machine itself rather than crashing the container. So that's something I want to resolve. And then again, because we want to make sure we're providing actionable advice to the developer for every vulnerability, we can basically say, here, add this bit of YAML to your deployment file to, to improve the security of your deployment and thus all the containers that it's running.
Yeah, awesome.
Yeah, it's cool stuff. I can go on and on about Snyk. That's basically my job, is to nerd out and talk security all day. So definitely would love to entertain any conversations around beyond just the container experience, kind of the infrastructure as code, the open source security, which we looked at a little bit, but it's really where we kind of started making our name. And then most recently, we've got Snyk Code, which is a first party static analysis tool, which is really kind of disrupting the way developers are looking at SAST as well. So a lot to cover another day. I did want to just do one last thing here, which is actually fix the issue that we started out with, which is we've got a bunch of vulnerabilities in this Docker file, right? If we remember here, I had changed this to node 10.4, which is a really insecure base image. So because I now have Snyk integrated with the Git repo that this came from, this Snyk/goof, I can go in, look at the Docker file, and I see those same vulnerabilities, right? Because we know we're using 10.4, node 10.4 as the base image. And this gets back to a question that James just asked in the chat, which is Snyk scanning all of essentially all images on Docker Hub on a daily basis? And the answer is yes, if they are Docker official images. And Peter, maybe you can talk a little bit more about this, but anything that's Docker official, Snyk is now going to scan so that we can provide that remediation advice. So what makes that really powerful in conjunction with some of the things you can do in Snyk is I can basically say, here's that same remediation advice again, right? We said node 10.4 has got those 454 high severity issues. But if I went all the way to the node 10.24-slim, I can reduce that to 16. Now we're going to do that in one click, right? What this does, opens a new pull request against that Docker file directly in my GitHub repository, and now the issue's fixed, right? We can even automate this entire process so that as soon as Snyk knows there's a change that can be made to the Docker file sitting in GitHub or in any source control manager, we can basically create automatically a new pull request that suggests that change. We'll tell you exactly why. Here's how many vulnerabilities you're actually covering. I'm reducing this from the 58 down to 72 by switching to this new version. And this is just staged as a regular PR in my code approval workflow. So it's almost more difficult to be less secure than it is to follow the upgrade advice and have more secure containers from the get-go.
Yeah, I think not much more to add on scanning on official images, right? I mean, that's one of the huge benefits of Hub is having, number one, that curated list of official images, and then they're scanned, right? And I just want to put in a talking point there that does not mean you shouldn't keep scanning, right? And checking for vulnerabilities, checking the images that come down, right? Doesn't remove the responsibility from the developer, but we're trying to help in that process, right? And do as many things as we can up front. Make sure we have good content on our registry for all of our customers, right? We have a couple more questions, but I believe we're at the end. Charlene's back on to yell at us.
Yeah. No, I would never yell at you, Peter. Come on. No, unfortunately, we're 3 minutes to the top of the hour. So, so that is all the time that we do have. And I do want to thank everybody for submitting questions because we had a ton of them. In fact, more than we could address during today's webinar. So please know that if we didn't get your question answered, that we are going to be giving the folks at Snyk a copy of all the questions that came in. So I'm sure somebody from the organization will be more than happy to follow up with you. Real quick, we had, I believe, one more polling question that we needed to disclose the results of. So I'll do that real quick, and then I'll do the closing housekeeping stuff. The let's see. The question was, are you running container vulnerability scanning on your Docker images today? The question, that looks like it was pretty much a dead even. 36% said no, and another 36% said no, but they plan to in the near future. So 27% said they currently are running container vulnerability scanning on their Docker images now. So that's a good thing. So real quick, thanks for putting that slide up that's got information on how to get Docker, get set up with Docker security on Snyk. Another real quick, the audience, to the audience, please know that reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section. It should be right there waiting for you. Before we close things out, I did promise 4 Amazon gift cards, $25 each. So without further ado, let's do that drawing. Our first winner today is Stephanie S. Congratulations. I'm sorry, Stephanie H. Sorry about that. Congratulations, Stephanie. Second winner today is Daniel B. Congratulations, Daniel. Third winner today is Dane O. Congratulations, Dane. And our fourth and final winner today is Tobias R. Congratulations, Tobias. Congratulations to all 4 of you. We'll be sending you a message via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Peter Clinton, what a great presentation. So much information. I kind of feel like we could have made this a 90-minute webinar and still would have run out of time. But thank you so much for your expertise and for all of the great information that you've imparted today. So really do appreciate it. I know the audience does too, based on the chatter and the questions that came in.
Yeah, awesome. That only means you have to have us back. So.
All right. Well, it's a date. So
Perfect.
I also want to invite the audience to come back and see us. But for now, this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.
Thanks all.